In this lesson, we'll be dealing with chemical reactions under chemistry. Chemical reactions. Now, this topic is very vital and important. If you are preparing for any of the external exams like NECO, WAEC, okay, and Jamb, most importantly, okay, Jamb, you will come across a lot of questions under this topic, okay, chemical reactions. And this topic is divided into two main parts: the chemical reaction, this is the first part, and reduction and oxidation reaction, where you will be asked to, because some of the questions you come across will be under chemical reactions and at the same time calculations of oxidation number. Are you getting it? So you have to learn how to differentiate between oxidation and reduction. That is redox reaction. Are you getting it? So take note. So this is the first part, chemical reactions. Are you getting it? So the aspect of oxidation and reduction reaction will be a lesson. Okay, it will be a separate lesson. Are you getting it? So let's deal with chemical reaction in this video. Now, if you are being asked, make sure you are writing everything down. If you are being asked, what is the meaning of chemical reaction? What do you understand by the word or statement chemical reaction? Now, what you should understand is in chemistry, okay, or um, yeah, especially in chemistry, before a chemical reaction must occur, there must be combination or like coming together or aggregation of different what substances or particles. Are you getting it? There are some things that must come together to form new substances. Are you getting it? So let me quickly give you the definition. So make sure you are writing everything down. Now, chemical reactions are changes in which chemical reactions are changes in which some new some new chemical substances are formed. Okay, are formed. Write it. Then the substances, this full stop, okay, after formed, you indicate it with what? Full stop. Then write the substances which undergo the chemical change, the substances which undergo the chemical change are known as reactants. While at this comma, okay, while the new substances while the new substances formed are called products. Are called what? Products. Now, this is what you should understand. If you are being asked what is the meaning of chemical reaction, chemical reactions are changes in which some new chemical substances are formed. Okay, then the substances which undergo the chemical the chemical changes. Okay, I didn't put changes. You can either put chemical changes or chemical reaction, okay, which undergo the chemical reaction. Put your reaction here, okay. So the substances which undergo the chemical reaction are known as what? Reactants. While the new substances formed are called what? Products, or are known as the products. Now, from the starting, I said something. I said before chemical reaction can occur, there must be coming together of different substances, isn't it? Let's say A is reacting with B. A is what? Reacting with B. It will form what? C and D. Are you getting it? Meaning that before C and D, okay, before C and D can be formed, there must be a reaction of what? A and B. So the ones that are reacting, they are always what? Or they are what? They are starting the reaction. They are what? On the left side. They are called the reactants. Are you getting it? The ones that are reacting, they are called what? The reactants. While the new substances that are being formed are called the product. They are on the right side. Are you getting it? They are what? On the right side. Okay, the ones that are reacting, okay, you can see that A and B are reacting. The reactant can be more than two substances, or can be more than two react. Are you getting it? It can be more than two reactants. So the reactants can be either two, three, four, okay, depending on that type of reaction, or the type of reaction that is what taking place. Are you getting it? So it's not compulsory that it must be two reactants, no. Okay, but the main thing here is the ones that are reacting on the left side, they are called the reactants, while the ones that are being formed, are you getting it, on the right side, they are called the what? Products. They are the new substances that are being formed from the what? Reactants. Are you getting it? So take note. Now, in chemical reaction, we have different types of chemical reaction. Okay, there are different reactions. Okay, there are different and they are grouped into almost like 7 to 8 of them. So we take note of about 6 of them, then I think it's 7. All right, let's continue. There are different types of reactions. Okay, or just write types of chemical reactions. Okay, types of chemical reactions. Types of chemical types of chemical reaction. Okay, types of chemical. Okay, now number one, write them down. Write them down. Number one, we have combination reaction. Number one, we have combination. Number two, we have decomposition. Decomposition reaction. Okay. Number three, we have displacement. Displacement reaction. Make sure you take note of all of them. Okay, displacement reaction. Then number four, we have double decomposition. That is double decomposition. Okay, double decomposition. The last one is N. Double decomposition. Number five. Number five is catalytic reaction. Sorry, catalytic reaction. Make sure you put reaction at the end of everything. Okay. Then we have reversible reaction. Reversible reversible reaction. Then number seven, we have thermal dissociation. Okay, thermal dissociation. Then number eight, okay, we have oxidation, oxidation, oxidation and reduction. Okay, oxidation and reduction what? Reaction. So these are the um, types of reactions we have. Take note of them. So you can be asked which of the following is not a group of reaction, okay, or is not a type of reaction. So take note, we have combination, decomposition, displacement, double decomposition, catalytic reaction, reversible thermal dissociation, and what? Oxidation and reduction reaction. Are you getting it? So make sure you take note of it. It's very important. Take note of them. Okay, now let's start from the first one, combination. Combination. Okay, what is the meaning of combination reaction? Okay, what is the meaning of combination? Now, from the word combination, I believe you can say something, isn't it? Combination is from the word combine. I get it. Two things or two or more things combining, coming together to form another thing. Are you getting it now? So that is just the meaning. So let me give the definition of combination. Okay. So when, right, when two or more, when two or more substances, when two or more substances combine, are you getting it? When two or more substances combine to form one single compound, one single compound, okay, or combination reaction is said to be have taken place. Okay, so this is the meaning of what? Combination. When two or more substances combine to form one single compound. Are you getting it? So it can be, let's give examples. Example, it can be what? Element plus element, isn't it? Element plus what? Element will give us what? Element plus element will give us what? Compound. This is, okay, will give us compound. Write it. Compound. Compound. So element plus element will give us what? Compound. Write it. Okay. So example, let's use iron. Iron is an element, right? So you can iron reacting with, let's use okay, sulfur. Iron reacting with sulfur. That is iron is solid. Then sulfur 2. Then it will give us what? Iron sulfide, right? That is, yeah, solid. Are you getting it? To give us what? Iron, or call it iron 2 sulfide. Sulfide, okay? Iron 2 sulfide. Now, element plus element will give us compound. So you notice that this is a compound, okay? This particular one is a compound. So these are the two words. We call these ones the reactants. Are you getting it now? The ones on the left side reacting, while this particular one is called the what? Product, which is what? The compound. So the ones on the left side, they are the ones, they are the elements, and also they are the ones reacting. So they are the reactants. While the one on the left side is the product, which is what the compound, the new substance that is what being formed. And at the same time, it's not only elements that can react to form, or that can react. Okay, compounds too can react to form bigger compounds. Are you getting it? Compounds too can react to. So write it down. Compound. Compound plus compound. Compound plus compound will give us. In chemistry, make sure you are using arrow. Don't use equal sign. Okay, make sure this arrow. So compound plus compound will give us what? Bigger compound. Bigger what? Compound. Write it down. Okay. What did I said? I said it's not only elements that can combine or that can react to form new these things, new substance or the product. Compound too, okay? Compound too can what? React to form bigger compounds. I get me. So example, let's use lead 4 oxide. Okay, lead dioxide, that is Pb as a symbol of lead. Okay, then reacting with sulfur dioxide or sulfur oxide. Okay, which is a gas, G gas. Then this one is solid. Okay, so it will form. That is lead. For then, yeah, this is a bigger compound. Are you getting it? This is what? A bigger compound. Okay, lead what? Sulfate. Now, you notice that this one too, okay, is a compound because it's being formed by what? Lead and oxygen, isn't it? This one too is a compound. Sulfur and oxygen. This one too, it contains what? Look at it, a bigger compound. You notice that it contains how many elements? Lead, sulfur, and oxygen. It contains 3 elements, different. Are you getting it now? So two compounds can also what? Can also come together. They can also combine or react to form what? Bigger compounds. Are you getting it? This is solid. So take note. Okay, so this is the meaning of combination reaction. Okay, two or more elements or compounds coming together, combining to form new uh, new or substance or the product or a new compound. Are you getting it? So please don't forget. So the second one is what? The second one is decomposition. What is the meaning of decomposition? So what is the meaning of decomposition? Now, in the aspect of decomposition, decomposition means one single compound splitting or decomposing to form smaller compounds. Are you getting it? It's just in form of, okay, let me just give you decomposition reactions. Okay, decomposition decomposition reaction are characterized, okay, characterized by a single compound, okay, by a single what? Compound splitting splitting up into two or more simpler what substances. Into two or more simpler substances. So like I said, decomposition reaction, okay, are characterized or is a type of reaction in which a single compound is dividing itself. Are you getting it? Dividing, separating to form more simpler compounds. Are you getting it? So let's now write down this statement. When heat, okay, it's very important, write it down. I will explain. It's very simple, don't worry. Chemistry is very simple. Just try your possible best, write and follow instruction, okay? Follow everything. When heat is needed to bring about the composition, the the reaction the reaction is known as thermal. The reaction is known as what? Thermal decomposition. Are you getting it? The reaction is known as what? Thermal decomposition. I said when heat is needed to bring about. What did I said about decomposition? I said decomposition is when a single compound splitting, dividing itself to what? To form or produce more simpler compounds, smaller compound, isn't it? So, but at the same time, when heat is needed, okay, when heat is needed to bring about decomposition, the reaction is known as what? Thermal decomposition. Thermal means something that is something when is referring to heat. Thermal means heat. Are you getting it? Now, meaning that there are some decomposition that can occur without heat. This is what they say. There are some what? Decomposition that can occur without heat, but the type of decomposition that occur as a result of heat, when heat is needed to bring about that breaking down of big compound to simpler ones. So that type of decomposition is known as what? Thermal decomposition. Are you getting it? Now let me give you some this thing like example. Let's say we have this lead nitrate. We have this compound that is solid. You notice that this is a big, like very big compound. Now this is the arrow. Heat is the catalyst here. Got it? Heat at the top side of the arrow. Now, um, in our like in coming lessons, we'll be learning how to balance chemical equation. We'll be learning how to name compounds. I get me. So we have a lot of things to do. So follow up, okay? So we have PB, or which is a solid. Then I think okay, nitrate. Then gas, hydrogen peroxide, then oxygen. So these are the simple what um Look at it. This is a big compound decomposing. I get me? Decomposing to what? To produce this simple or smaller compounds. And at the same time, an element. Are you getting it? So you notice that this was decomposition. So this type of reaction, is it just decomposition or thermal decomposition? You notice that this is called what? Thermal decomposition. Why? Because heat is what needed. Look at it. Look at the heat here. Because heat is what harder to bring about this decomposition. Are you getting it now? So when you see this type of reaction where a single compound splitting, okay, as a result of what? Heat to form simpler compound, it is known as what? Thermal decomposition. Okay? Thermal what? Decomposition. So write everything down. Hope you are writing everything. Write everything down. Now let's continue. The number three, or the next one is what? Displacement. Displacement reaction. Displacement what? Reaction. Now what is the meaning of displacement reaction? Okay, before I explain, write this down. In displacement, comma, one element, okay, in displacement, one element or radical, replaces one element or radical replaces another element. Are you getting it? One element or radical replaces another element or what? Radical. Okay, in a compound. In in the aspect of displacement reaction, one element will what? Replace the other one. From the word replace, to replace something. Are you getting it? Do you know that, okay, when so like in a church, when someone is playing drum, okay, when someone is playing drum, okay, this person not too sabi, so may I replace am based on say the other person sabi pass am. Are you getting it? Even in a fight, like let me say two people are fighting, let me say like all these fights, let me say to win something. I get it, to win something based on say that they beat your opponent. I mean your fellow this thing, your fellow like your colleague, okay, in the same team with you, based on say they beat am, like you wan go replace am based on say you strong pass am. Are you getting it? So meaning that before, now with this explanation you understand that before displacement will take place, um the other element that want to replace the this thing, the previous element must what? That one that want to replace it, that one must be stronger than that one. Are you getting it? That one must be what? Stronger. Okay? Or the radical that want to replace the previous one, that radical must be stronger than the other radical. I get me. So meaning to replace something, that is just the meaning. To replace. Okay, you not too strong, man replace you. You no reach me, man replace you. That is what to what displace. Now let's give example. Let's say we have this one reacting A plus what? A reacting with B Y. Okay, to form what? If we want to change this, let's say we take out B, then A what? Y. So what just happened here? We notice that here we have what? BY, isn't it? We have only A here. So from the product, we see that A has what? Replaced B, isn't it? Now it's B that is standing alone. Look at it, B is standing alone. So A has what? Replaced B. So this is mean of for displacement reaction. Are you getting it? Now there is something to understand, and I've said it before. I said before, meaning that we are assuming that A is what? Stronger than what? B. Are you getting it? A is what? Stronger than B. So mean that if A is not stronger than B, okay, A cannot replace B. This is what you should understand in displacement reaction. Now write this thing down. The ability of an element or radical, write it down. The ability of an element. The ability of an element or radical to displace, okay, to displace another is determined by their relative positions in the what? In the electrochemical series. In the electrochemical series. Now, electrochemical series is just we get to that topic under we you will learn it under hydrogen and its compound. When we get to that topic, you know how the electrochemical series is. It's just form of an hierarchy, okay, where we have element that can displace hydrogen from either cold water and the rest. I get me. There are some elements we call electropositive element in the aspect of positivity. Like this is what um negative, right? This one is positive, right? So there are some elements that are very electronegative, meaning in the negative aspect, while there are some elements that are very electropositive, they are very positive. Are you getting it? So meaning that in the aspect of positivity, okay, in the aspect of positivity, okay, even those elements, there are some elements that are under positivity, that are under positive, okay, while there are some elements that are under what? Negativity. There are some, they are very negative, negativity and what? Positivity. So when we read that topic, you will see how the hierarchy is, okay, but just try to understand what I'm trying to explain. Now, those elements, let's say we have example. I want to explain something. Don't write this thing. Okay. Let's say we have, okay, let's say examples of let me say electropositive element. Let's say we have A, we have B, we have C, we have D, we have E. I getting it. Do you know that even all these are example of what? Electropositive element. Are you getting it? Okay, I'm just trying to use ABCD to explain to you. So let's say all these are examples of electropositive element. Do you know that even these positive element, there are still so they have like hierarchy. There are still some of them that are more electropositive than the other ones. Are you getting it? Okay, let's say we have five persons in a particular place, and all of them they are rich. I get me. they are wealthy. All those 5% are wealthy. Do you know that even out of those 5%, we still have one particular person that is more richer? Isn't it? All of them they get money, oh, all of them normally they get billions, but still here there is still one particular person among those people that still have what the highest amount of money. Are you getting it? Followed by the second person, followed by third, fourth, and fifth. Even the last person self, that person is very wealthy, very. Are you getting it? But all of them in general, they get money. Are you getting it now? So from A to E here, all of them they are what electropositive element, but still yet, let's say A is more electropositive than B, then B is what is what more electropositive than C, then C is more than D, then D is more than E. Are you getting it? The same thing with electronegativity. Okay, there are some elements that are very like very what negative. Right? I get it. But still, yeah, there are still some of them that are more what electronegative than others. Are you getting it now? So let's use or like one example. Okay, so you understand better. I believe this explanation is clear, right? Let's use like zinc. Zinc that is solid reacting with um let's say copper sulfate, reacting with copper that is aqueous solution, okay, to give zinc sulfate plus copper, which is what solid. This one is what aqueous. Now can you identify what just happened here? But you notice that zinc, copper has been replaced by what? Zinc. Can you see it? Here we have copper, so here we have copper. Zinc is just standing alone. But here, look at it. Zinc now what? Is now taking the position of what? Copper. Look at copper here. Are you getting it now? So meaning that, so what can you say? Can you say anything? You notice that, so you can conclude that zinc is more what? Electropositive. So you will take note of um electropositive elements. Okay, this is an assignment. Those of you in my lesson group, do it, okay, and submit assignment. Write down 10 electropositive and 10 electronegative elements and submit in the interacting group. Are you getting it? Submit what in the interacting group? 10, write it down, 10 electropositive element and 10 electronegative elements. Write them down in the interacting group. Submit, I mean submit in interacting group. Okay, after watching this video, do it and submit. That's what I'm saying. So zinc is an electropositive element, copper too is an electropositive element. Okay, so you can see that zinc has what replaced copper, meaning that zinc is more electropositive than what? Copper. Are you getting it now? So this is the meaning of what? Displacement. One replacing the other one. But before replacement or displacement can take place, the other one must be more electronegative or must be more electropositive than the other one is what? Replacing or displacing. Are you getting it now? And also chlorine and potassium. Now let me give you this one. Okay, chlorine is an electronegative element. Okay, reacting with potassium bromine. Okay, that is in aqueous solution. Then this one in aqueous is potassium chloride. That is, then we have bromine, that is liquid. So look at it. You notice that what just happened? You notice that, look at it. Um Chlorine has replaced what? Bromine, isn't it? Chlorine, chlorine what? Replace what? Bromine here. Look at it here. But come to this place. Potassium is still here, but bromine is what? Is alone here. Look at it. It has been replaced by what? Chlorine. So meaning that chlorine is more what? Electronegative than what? Are you getting it? So this is how displacement reaction occurs. Okay. Now let's look at double. The next one, that is the fourth one, right? Double what? Double decomposition. Double decomposition. Are you getting it? Double what? Decomposition. Double decomposition. Now, what is the meaning of double? But you understand the meaning of decomposition from the previous thing, right? So, double means what? Two. Double, meaning that two bigger compounds, right? Two compounds that was splitting. So let me give you a definition. So you write, in double decomposition, in double decomposition, okay, comma, the reactants decompose to form new substances by an exchange of radicals. Let's say we have AB reacting with CD to give AD plus what? CB. Now, before I explain this particular one, write this statement down. A double decomposition reaction, a double decomposition reaction is used in the preparation of an insoluble or volatile compound. Okay, a double decomposition reaction is used in the preparation of an insoluble or volatile compound. Now make sure you write this statement down. A double decomposition reaction is used in the preparation of an insoluble or volatile compound. Right? Now, what is the meaning of insoluble? This word, what is the meaning of insoluble? Insoluble means when something is, or like when something cannot dissolve in another what substance. Let's use this one as a very good example. You know gravel, right? Gravel. Do you know that if you add gravel to water, there is no way that gravel will dissolve, isn't it? That gravel will not dissolve. Also, if you add stone to water, that stone cannot dissolve in water, isn't it? So that gravel you add to water that cannot dissolve, we call it what? Insoluble. It cannot what? Dissolve in that water. If you add substance to water or to any other like like organic compounds or inorganic compounds, okay, the simplest form is when you add substance to another substance and that substance you added, okay, dissolves in that other substance, meaning that the substance you added can be what? Dissolved, or it is what? Soluble, okay, it is what? Soluble. So meaning that soluble means what? Soluble. Soluble. This is spelling. Okay, soluble means it can what? Dissolve. This is V. It can dissolve. But insoluble means cannot dissolve. Insoluble. Are you getting it? Mean cannot dissolve. Are you getting it? It cannot dissolve. Are you getting it now? Soluble means what? Something that can be dissolved. Okay. While insoluble means something that cannot be dissolved. So if they ask you what are examples of soluble substances, soluble, okay, soluble, not soluble, soluble, okay. So if they ask you what are examples of substances that can, okay, examples of soluble substances in water, okay, you can mention, right, something that can dissolve in water. Can shock dissolve in water? Do you know shock? That substance they use in writing in all these dark boards in our secondary school, they use shock now, isn't it? Can shock dissolve in water? It can, right? Yeah. So when that shock is an example of what? A soluble substance, right? It can be dissolved in water. I get me. But one thing you should understand is some substances, like example, or let me use shock. If shock can dissolve in water, I'm just citing an example. If shock can dissolve in water, if you put shock in other liquids, it cannot dissolve. Are you getting it? I'm just citing an example. I'm telling you that there are some materials or there are some substances that can dissolve in this particular one, but if you put them in other substances, they will not dissolve. Are you getting it now? So there are some substances right there. So any substance that can be dissolved, it is what soluble, it can be dissolved. But if that substance cannot be dissolved, if it does not dissolve, meaning it is what? Insoluble. Are you getting it? So what is the meaning of volatile? Okay, volatile substance. Look at it, volatile. Now, volatile means something that is in form of in a gaseous form. Okay, in a gaseous form. Now, some substances, I told you that in the meaning of chemical reaction, one, two or more substances will react to form what? The product, isn't it? Let's say to form C plus Z. Now, these are the reactants, right? These are the ones reacting. Why these are what? The product. Now, what you should understand is these products, okay, these two products you are seeing here, one, sometimes most reactions, one of these products will be a volatile what? Substance. Volatile means something that can easily escape. I told you guys in the gaseous form, something that can easily escape to the what? To the air or to the atmosphere. It will just escape, right? This thing. Like that. When we get to this particular topic, what is it called? I think it's equilibrium. Yeah, equilibrium. Yes, equilibrium, where we will discussing about forward and backward reaction. Okay, forward and backward reaction, how they can attain the state of equilibrium. Okay, so when we get to that topic, you understand better. But for now, just know that there are some products that when they formed, There are some products that will be in a volatile form. I get me in form of gaseous. So volatile means something that can easily escape to the atmosphere, or something that is not stable in a particular place. Something that is not stable. I get me. Just trying to run away. Something that is not stable. When we say someone is volatile, meaning that person is not stable, that person is just trying to like run away. It's not a calm person. Are you getting it now? So there are some substances like that in the gaseous form that once they are formed, they are not, unless you close them before they can be inside a container. But even when they're in that container, they are still what fighting, struggling to escape. I get me. So there are some substances like that. So make sure you write this statement down. A double decomposition reaction is used in the preparation of an insoluble or volatile compound. I get it. Now let's move to the next one, which is catalytic catalytic reaction. Catalytic reaction. This one is number 5. I think this is the number 5 one. Number 5. So catalytic what reaction? Catalytic reaction. Just complete the spelling. Catalytic reaction. Okay. Now let's discuss this particular one, and this one is very very important. Okay. This one is very very important. Catalytic reaction. Now, if I may ask, what is the meaning of catalyst? Now, there are some reactions. Are you getting it? Let's say we have this reaction here, A plus B, A reacting with what? B to form C and what? D. Now, do you know that there are some substances before they will reach the or before they will form this product, it will take them a lot of time. Or there is something you call equilibrium state. Are you getting it? So before, but what you should understand is there are some reactions, okay, before they will form this product, before they will react to form this product, it will take a lot of time. Are you getting it? That's why reactions differ. There are some reactions that will take them lesser time, before few minutes, they will just or few seconds, minutes, depending on hour, they will just form. But there are some reactions that it will take them a lot of time. Sometimes it will take a lot of time for them to form the product. Are you getting it? So now what chemistry will do is, okay, if we leave this reaction now, it will waste our time. Are you getting it? It will waste our time before they will form the product. We will keep standing here. So what must be done for this type of reaction to be fast, to react very fast to form the product? They now introduce what they call what? Catalyst. Are you getting it? They now introduce this particular catalyst. So this catalyst is a substance that increases the rate of a chemical reaction. Are you getting it now? Catalyst, I will write it down, and there are a lot of things under this catalyst. Okay, but the brief definition, the shortest definition you can ever point out from catalyst is catalyst. Now write it. Catalyst is a substance. It's a substance that increases the rate of a chemical okay reaction. Catalyst is a substance that increases the rate of a chemical reaction. So this is the work of what um or the duty of catalyst. Okay, so let's write something. Certain substances are used to alter the rate of a chemical reaction. Now, write this statement down because in the exam they might use this statement to confuse you. So, write it down. Certain substances are used to alter the rate of chemical reactions. Okay, the rate of chemical reactions, full stop, then write. Make sure you are very fast in writing. These substances which remain chemically and quantitatively unchanged. Okay, quantitatively unchanged at the end of the reactions are called or are known as catalysts. Are known as what? Catalyst. So I said the shortest definition you can ever give about catalyst is what? They are substances that what increase the rate of a chemical reaction, right? They increase the rate of a chemical reaction. Now, what did you understand this saying? Look at this second definition. I said certain substances are used to alter. Certain substances are what? Are used to alter the rates of chemical reactions. Meaning to change. Alter means to change, okay? To change the rate of, to change how those reactions, okay? To change how they move or how they react. To change their speed of reaction. That's what I explained, right? Their speed. So that they will either attain the equilibrium state or to what form the product very fast. So now these substances which remain chemical unchanged, what you should understand is these catalysts, their duty is to increase the rate of a chemical reaction, right? But what they normally do is they remain unchanged at the end of the reaction. Their duty is to what? Increase or increase the rate of a chemical reaction, but they still what? Remain unchanged at the end of that reaction. They does not what? Change. Are you getting it? So they still remain like that after the reaction. They still remain like that. Okay, chemically and quantitatively. The quantity you add quantitatively means from the word quantity. And what is not quantity? The amount, the quantity, the amount. So after the reaction, those catalysts, they at least if you add something, it's supposed to melt or I get it. But these catalysts, after increasing that chemical reaction, they still what? Remain chemically unchanged. Also, that amount you added is still the same. They remain unchanged at the end of the reaction. Look at it. So those substances are known as what? Catalysts. So this is the meaning of catalyst. Okay. So meaning that any reaction, okay, that uses a catalyst, it is called what? A catalytic reaction. Write it down. Any reaction that uses a catalyst is called A catalytic reaction. A catalytic what? Reaction. Now take note. I've told you before, I said it's not all reaction that we use what or that must use catalyst. Whenever someone is using catalyst for a particular reaction, meaning that that reaction is very slow. So meaning that there are fast reactions, okay? There are fast chemical reactions that you do not what need or use catalyst. I get it. So those there are some reactions that can like they are very fast. They don't need your catalyst. They are very fast. I get it. They will react very fast. They will react very fast to form the product. So the only time they use catalyst is when a particular reaction is very slow. Are you getting it? So meaning that it's not all reaction that uses catalyst. This is what you should understand. Are you getting it? The only one, as I'm talking, you need to be jotting things down. This is our smart student. It's not everything that we will be writing. Are you getting it? So try to form word like statement, okay, as I'm talking, okay. So it's not all reaction that uses what catalyst, okay. So I said the only time they use catalyst is when that reaction is very slow, okay. So take note. Now let's look at something, okay. There are two types of catalyzed reactions. Now let's know the meaning of homogeneous and heterogeneous catalysis, okay. Very, very important. Homogeneous. Okay. Homogeneous. Is it homogeneous? Homogeneous and heterogeneous catalyst. Heterogeneous catalysis. Homogeneous and heterogeneous catalysis. Okay. Now let's start from homogeneous. Homogeneous what catalysis, right? The catalysis at the front. So let's start from homogeneous catalysis. Now, right, in this reaction, comma, the catalyst in this reaction, the catalyst in this reaction, the catalyst reactant in this reaction, the catalyst, comma, reactants, okay, reactants and products are in the same phase. Are what? In the same phase. Are in the same phase. Okay. What does it mean? I said in homogeneous catalysis, in this reaction, the catalyst, comma, the reactants, okay, that is reactants and the products are in the same phase. There are three words here, take note of them. Number one is what? In this reaction, the catalyst, comma, that is the first one, catalyst, right? The catalyst, number one, reactants, number two, and what? Product, number three. All are in the same phase. Are you getting it? Now, what does it mean? What does it mean? Let me show you with example. Okay. Now, oxidation of sulfur 4 oxide using nitrogen 2 oxide is okay, as catalyst occurs in the gaseous phase. Now, write it down. Example. That is example of homogeneous catalysis. Okay. Example of Example of homogeneous catalysis. Okay, just write only one. By using this one to cite example, you understand. Okay, so take note. Now, oxidation. Okay, I'll just write the oxidation, not oxidation alone. The oxidation of sulfur 4 oxide. Just write, I will explain. It's very simple. Okay, chemistry has a way of confusing story, but I will break down everything. So don't worry, just write. The oxidation of sulfur 4 what? Oxide using nitrogen using nitrogen 2 using nitrogen 2 oxide as what? As catalyst occurs in the what? Gaseous phase. Now from this statement, this is the reaction. Write everything. This is gas, sulfur 4 oxide is gas. So sulfur 4 oxide reacting with this thing, oxygen is also a gas. Okay, so this is to form what? To form. So here the top side of the arrow is this thing, nitrogen 2 oxide, that is a gas. Okay, so to form this 2. Okay, now this is what you should understand. Okay, this is what now the oxidation of sulfur 4 oxide. Okay, using nitrogen 2 oxide as a catalyst, the gas. Now look at it. I want to explain something. I said this one is an example of what? Homogeneous catalysis, right? Or homogeneous reaction. Okay, either homogeneous catalysis or homogeneous what? Reaction. Are you getting it? Now look at it. The oxidation of sulfur 4 oxide using, what is the meaning of oxidation? When a particular reaction involves what? Oxygen, isn't it? Oxygen. Now, the oxidation of sulfur 4 oxide using nitrogen 2 oxide as catalyst occurs in gaseous what? Phase. Now look at it. If you go back to the first write-up I gave you, I said, what is the meaning of homogeneous? I said, in this reaction, the catalyst, number one, the reactants, and the product are in the same phase. I said something like that, right? Now look at it. The reactant, these are the reactants, isn't it? Then the catalyst. Now, for you to identify a catalyst, catalysts are always written at the top side of a given arrow. Are you getting it? The top side of the arrow, that it can be an element, it can be a compound. Are you getting it now? Catalyst can be a element, or it can be a what? Compound, or it can be any gas, it can be a solid. Are you getting it? So take note. Now these are the reactants. Why the one at the top of the arrow is the what? Look at it. Is a what? Nitrogen 2 oxide is a what? The listing, the catalyst. Are you getting it? Why the product here is this one, right? Which is sulfur 6 oxide. Okay, sulfur 6 oxide. So now look at it. To identify an homogeneous what reaction or homogeneous catalysis, I said all the three components like the reactant, the catalyst and the product must be in the same phase. Are you getting it? Meaning that if the reactants are in the gaseous phase, the catalyst too must be in gaseous phase, and also the product too must be in gaseous phase. If the reactants are all solid, the catalyst too must be solid. The product too must be solid. If the reactants are liquid, then all the rest, both the catalyst and the product must be liquid. Are you getting it? So meaning that if as a result where one of them, let me say both the reactants and the catalyst are in solid, then the product is in liquid form or gaseous form, that one is not a what an homogeneous reaction. So for it to be an homogeneous reaction, this particular reaction, it is called what it is an example of what homogeneous catalysis or homogeneous reaction. Why? Because both the reactants, look at it, everything, are you getting it now? Look at it, gas, all of them are in what? Gaseous phase. Look at it, I mean, gas. Look at the catalyst, gas. The product, gas. Are you getting it now? So meaning that once you notice, they can ask you which of the following is an homogeneous reaction or homogeneous catalyst. This catalysis. What you need to do is what? Look at the downside. If all of them, all are you getting it? All of them must be the same. If all of them are all in gaseous form, or if all of them are all in liquid form, you will see the symbol. G stand for gas, okay? S, if it's S there, it is solid. If it's L, that is liquid, okay? So mean that um like no matter their phases, okay, meaning they must be in the same phase. Either they must be, all of them must be in gaseous phase, or all of them must be in liquid phase, or all of them must be in solid phase. The thing is they must be in the same phase. Are you getting it? So meaning that if all of them are in the same gas, or liquid, or solid, meaning that reaction is an example of what homogeneous reaction. So this particular reaction is an example of what homogeneous reaction. So meaning that if you see any reaction, you can easily identify, okay, this one is an homogeneous reaction, right? It's very simple. Are you getting it? So now look at, no, okay, now that you can identify an homogeneous reaction, now what is the catalyst here? The catalyst is what? Is this one, isn't it? I said the top of the arrow, that is where the catalyst is. If you see any chemical reaction, just check the top of the arrow. If there is any element or compound there, know that that is a what? Catalyst. So the catalyst used in this process is what? Nitrogen 2 oxide. So now take note, meaning that from this statement, the oxidation of sulfur 4 oxide to form what? Sulfur 6 oxide. This one is sulfur 6 oxide. Oh. Okay. Sulfur what? 6 oxide. Why this one? This one is this NO. That is the catalyst, okay? Is what? Nitrogen 2 oxide. Okay, nitrogen 2 oxide. So this one is sulfur 4 oxide. This SO, this thing. Then this one is oxygen. Are you guessing it? So meaning that, look at it, meaning that the oxidation of sulfur 4 oxide, okay, to form sulfur 6 oxide, what catalyst is used? Nitrogen 2 oxide. Repeat, nitrogen 2, because in the exam they will ask you these questions. That's why we have a lot of formulas, a lot of chemical reaction that you use for different types of catalyst. I get me. So meaning that the formation or the oxidation of what sulfur oxide to form sulfur 6 oxide. The catalyst used is what nitrogen 2 oxide. So don't forget, okay. So I believe you can identify an homogeneous what reaction or homogeneous catalysis. Now number two is what heterogeneous. How can you identify an heterogeneous reaction? Heterogeneous. Okay. Now right in this reaction, the catalyst then reactants and products okay and products are all in different phase, okay, are in different phase. Are in different phase. Okay, this one is then E. Are in different. This one is T. Sorry, this one is T. Are in different what phase. Okay, I said in the aspect of homogeneous, I said all of them are in the same phase, but this heterogeneous meaning that in heterogeneous it's just the opposite of homogeneous. I get me. In homogeneous all of them are in the same phase, but in heterogeneous all of them are in what different phase. Now look at it. In this reaction the catalyst reactant and the product are in different what phases. Okay, they are in different phases. Now let me give example. Okay, example. Okay, examples of heterogeneous reaction or catalysis. Okay, now the first one is we have nitrogen, which is a gas, then reacting with hydrogen, which is also a gas. The catalyst here is iron, which is a solid. Then this one is backward and just draw it like this. Then to give ammonia. Now look at this reaction. Look at this reaction. Is this one homogeneous or heterogeneous? Is what heterogeneous because what look at it. The reactants are all in what gas, right? The product is in what gas, is a gas, look at gas, but the aspect of catalyst is in what solid. So mean that one of them, as far as one of them is in a different phase, that reaction is what heterogeneous what reaction or catalysis. So take note, don't forget. So meaning that the formation of ammonia, okay, This one is ammonia. Okay, ammonia. Okay, ammonia. That is NH3 is ammonia. But there is one particular one that is like this NH4. Okay, this one is what? Ammonium. Ammonium gas and ammonium. So take note. So the formation of ammonia, the catalyst used is what? Ion. Fe is what? Ion. So take note of all these things. So the formation of ammonia, so meaning that nitrogen combined with what? Hydrogen to form ammonia. So the formation of ammonia, the catalyst used is what? Ion, right? So let me give you another example. Example 2, let's say, example 2, let's say we have this particular one. Hydrogen, okay, which is a gas, reacting with iodine, gas, okay, then um then to form, what is this? Hi. Are you getting it? What is the full, what is the meaning of Hi? Hydrogen what? Iodide, right? Then this thing used, the catalyst used is PT, that is platinum. Okay, platinum. This is spelling. Platinum, this N. Okay, platinum. Now, platinum is solid. Now, you notice that, look at this one, the reactants are in what? Gas, right? The product too, gas. But this thing, the catalyst is in what? Solid. So this one too is an heterogeneous reaction. Now, take note. It doesn't mean that like it's not only the catalyst that always be in different phase. So no, sometimes there are some reactions we see that the reactants are in different phase. Sometimes the catalyst and the product are in the same phase, okay, but the reactants will be in different phase. I guess me. So what you need to know is, as far as one of them, if one of them, either it can be the reactant, it can be the catalyst, it can be the product. I get it. So as far as one of them are in different phase, okay, if they are not the same phase, if they are not in the same phase, that reaction is what? Heterogeneous. Are you getting it? So take note. So now you can identify, right? If you see a chemical reaction, you will easily notice that this one is homogeneous, this one is heterogeneous. So meaning that the formation of hydrogen iodide, the catalyst used is what? Platinum, right? Take note to take note. Now, write this statement is very important. The formation of margarine from vegetable oil in the presence of nickel. Okay. Write this statement that is very important. The formation of margarine the formation of margarine from vegetable oil in the presence of a nickel catalyst is what? is also an example of heterogeneous catalyst. Okay, heterogeneous salt catalyst. Now write it to the formation of margarine from vegetable oil in the presence of a nickel catalyst is also an example of what? Heterogeneous salt catalyst. Are you getting it? Now, this is the reaction of this statement: vegetable oil, which is what? Liquid, abi this L, okay, reacting with hydrogen, which is the gas, no space again. So just write it. Vegetable oil that is liquid reacting with that is plus hydrogen, which is the gas. Then we say this thing nickel, right? Which is Ni, which is solid, to form what? Margarine. Margarine is solid, okay. Now, if you are confused the meaning of margarine is just a processed butter, okay, used for spreading or baking and cooking. Are you getting it? Now, the normal butter you use, like you eat, the normal butter you use in, let me say, you can add butter to bread, right, and eat. But this particular margarine, okay, is a processed what? Butter. That normal butter you use to, let me say, to add this thing, you add it to bread, right? That normal one is gotten from all these animals. I guess it animal milk or all these animal fat. But this particular margarine butter I'm talking about is processed from all these vegetable oils. Are you getting it? Vegetable oils like all this, it can be gotten from this palm oil. Palm oil, right? Palm oil, that's palm oil here. Then soya bean oil. I getting then sunflower too. Okay, and also from, so it can be gotten from all these palm oil, soya bean, sunflower. I getting it? So take note. That is mean of margarine, okay, just in form of a processed butter that can be gotten from palm oil, soya bean oil, okay, but so it's not exactly the same with that normal butter you are eating. I get me. So meaning that vegetable oil, the formation of margarine, the formation of what? Margarine, what catalyst is used? Nickel, right? So this one is also an example of what? Heterogeneous, isn't it? Look at it. Gas, the reactants are what? Look at it. The first reactant, vegetable oil, is in liquid. Hydrogen is what? Gas. Then catalyst, solid. This one, product, solid. So meaning that you can now notice that this one is what? Heterogeneous, isn't it? So take note. Now let's look at the characteristics. Okay, characteristics okay characteristics of a catalyst. So all these are past questions. They will ask you which of the following is not a characteristics of what, or all these are features. Okay, and that word for catalyst is what? Feature. So they can ask you which of the following is not a characteristic or which of the following is not a feature of catalyst. I get me. So you have to know all the characteristics of catalyst. Now, number one, a catalyst, okay, right? A catalyst alters the what? The rate of a chemical reaction. Number two, a catalyst remains what? Unchanged. Right, very fast. Unchanged in chemical nature and mass at the end of a reaction. Its physical features um coming its physical features such as color and texture may be changed. Okay, may be changed. Then number three, a catalyst, okay, oh, a catalyst is specific. Okay, a catalyst is specific in action. Okay, it's okay, meaning that a given catalyst will act on only one particular reaction, although okay, although many inorganic catalysts will catalyze than more than one reaction. Then number four, a catalyst cannot start a reaction. It is effective only in a reaction which is already in progress. Right, very fast. Number 5, right? A catalyst does not Number 5, right? Yeah, a catalyst does not affect the types of products formed in a reaction. Number 6, a catalyst okay a catalyst has no effect on the equilibrium of a reversible reaction. Okay, then number 7, don't be tired of learning, don't be tired of writing. Okay, if you like dey complain for there na you sabi. Let's continue. A catalyst will affect me with dey teach and dey complain na you dey complain. A catalyst will affect the rate of a reaction even though it is present in very small amounts. Full stop. Then an increase in the amount of catalyst up to a certain limit however would usually increase the reaction rate. Number 8, the last. The effect of a solid catalyst is improved by increasing is improved by increasing its surface area. Is what? Surface area. So full stop. Okay, surface area full stop. Now this is addition. Note. Okay, note since a catalyst does not affect the overall reaction, it is written above the arrow in an equation. Are you getting it? So for you to identify a catalyst, the above arrow, the top of the arrow, anything is there, that is what? The catalyst. Okay, so these are the characteristics of catalyst. Number one is what? A catalyst alters the rate of a chemical reaction. I've explained this before. It changes or speeds up. Alters means to change. Okay. If a chemical reaction is slow, it will what? Speed up that reaction. So number two is what? A catalyst remains unchanged in chemical nature. I said after what it does is to speed up, but it will not what change chemically. But what you should understand is the physical features like color and texture can be changed. Okay, but the chemical nature remains unchanged. Now, number three is what? A catalyst is specific in action. A given catalyst will act on only one particular what reaction, although many. So a catalyst is what specific. Okay, the main purpose you are adding that catalyst is what it will what function. Are you getting it? Is what it will is what that catalyst will function. Okay. Now a catalyst cannot start a reaction. It is effective. Catalyst cannot start a reaction. It is always effective like when a chemical reaction is already in progress. I get me when a chemical reaction has already started before that catalyst will be very effective. Okay. Now a catalyst does not affect the type of product formed in a reaction. Okay, it does not affect the type of product formed. Okay, so a catalyst has no effect on the equilibrium of a reversible reaction. Reversible reaction means a reaction that can go forward and back. Okay, that's why some reactions you will see these two arrows, one going forward and one coming back. Isn't it? Have you not seen this type of reaction? The middle, you will see these two arrows. So one is forward, that is going forward reaction, while the one is this one that is pointing back is what referring to backward reaction. So the combination of forward and backward reaction, that is what irreversible. That is reversible reaction. Reversible. Okay, meaning it can go forward and okay, meaning it, and also it can what come back. Are you getting it? So that is it. So that's right. So the main reason why a catalyst is written at the top of arrow, the arrow is because look at it. Since a catalyst does not affect the overall reaction, it does not affect the overall reaction. It is specific. Okay, why the catalyst is added is because what is to what alter or speed up the chemical reaction. I getting it. So take note. So now let me give you the overall definition of catalyst. Write it down. So wait, make sure you take note of these characteristics because they will ask you which of the following is not a characteristic or feature of catalyst, or all these are catalyst definitions, or all these are characteristics of catalyst. Okay, so they can set the question in any form. All these are characteristics of a catalyst, except, are you getting it now? So you have to know them, if not you'll be confused. Okay, so a catalyst, write it down, is a substance. A catalyst is a substance which alters the rate of a chemical reaction but itself remains chemically and unchanged at the end of the reaction. They ask you what is a catalyst. You can say a catalyst is any substance that what alters the rate of a chemical reaction. Okay, so I think I've given you almost like three definitions. There's no way you will not get your full mark. They ask what is mean a catalyst. A catalyst is a substance which alters the rate of a chemical reaction, but itself remains what chemically and quantitatively unchanged at the end of the reaction. Hello, very good. So take note of them, okay, and read. Chemistry is very simple if you can put your mind together and study. Types of catalysts. So we have organic and inorganic catalysts, okay? Organic and what? These are the two types, organic catalyst, okay? We have organic and inorganic catalyst. Now, under organic catalyst, okay, now inorganic catalyst, inorganic is grouped or is divided, okay, is grouped into positive and negative what? Catalyst. Are you getting it now? It's grouped into positive and negative what? Catalyst. Okay. Why organic catalysts are known as enzymes. So full stop. While organic catalyst, okay, are known as enzymes. And are produced by living cells. That's why from the definition of enzyme is an what? Is an organic catalyst, usually proteinous in nature. which speed up chemical reactions, right? So meaning that enzymes are what organic catalysts. So that's why I can see. While enzymes are what? While organic catalysts are known as enzymes. So I believe you know the definition of enzyme from what? Biology, this thing, biology. So I said inorganic catalysts are, so the two types of this thing, catalysts are what? Organic and inorganic. Getting it? So now let's look at the positive and negative catalysts. Okay. Now the difference is, now in the aspect of positive catalyst, okay, positive catalyst, okay, let's just write, okay, positive catalyst, okay, just write is a catalyst that increases the rate of a chemical reaction, okay, is a catalyst, is a catalyst which increases the rate of a reaction. Are you getting it? Increase the rate of a reaction is a positive catalyst. Are you getting it? So any catalyst that increases the rate of a chemical reaction, those ones are what are called what? Positive catalyst. Okay? Example is, example of positive what catalyst is what? Just write this one. Number one, manganese. Okay, manganese. Okay, or manganese. Manganese 4 oxide. Manganese 4 oxide, which speeds up the decomposition of potassium triiodochlorate 5, chlorate 5. Okay, so positive catalysts are important in chemical industry, okay, since they can speed up a low reaction. They are very important. So if they ask you what are, or what is the importance of positive catalysts, okay, they are very important in industries since they speed up low reactions. I get it. They increase the rate of what chemical. So an example of a positive catalyst is what? Manganese 4 oxide. Now this is the reaction. Look at it. This is a solid. This manganese 4 oxide. Okay. This is 2 at the downside 2. Okay. So this is this thing 2 potassium chloride. Then this one is solid. Then plus oxygen, which is gas. Now look at it. So manganese 4 oxide, okay, we speed up what? A decomposition of potassium triiodochlorate 5. Now look at, you notice that this particular reaction is what? Decomposition reaction. I guess we've done it now. When a single compound is what? Decomposing or splitting to form simpler compounds or elements. Now take note, the decomposition of potassium triiodochlorate 5. Potassium triiodochlorate 5. What catalyst is used? Manganese 4 oxide, okay, and it is what? A positive catalyst, okay. So the aspect of negative catalyst, just the opposite, okay. If a positive catalyst increase the rate of a chemical reaction, then what will be the aspect of negative catalyst? It will what? Decrease the rate of a chemical reaction, okay. It what? Decreases the rate of a reaction, okay. So example of negative catalyst, okay, negative catalyst, okay. Number one, right? Okay, tetraoxo, you like it, tetraoxo phosphate 5, okay, acid decreases the rate of decomposition of hydrogen peroxide while a 2% ethanol solution suppresses the oxidation of trichloromethane by air. Now let me give you the reaction, okay. So this is the reaction. Write it. There's liquid, what is the name of this compound? It's in the write-up. This is 4, okay. Draw your arrow well so that it will accommodate that this thing, that catalyst way. Then this one is liquid plus oxygen gas. So okay, write it. Now I said something. Now that catalyst, you notice that it's what? A negative catalyst. A negative catalyst, isn't it? So the name is what? Tetraoxophosphate 5, okay? Tetraoxophosphate 5. Now you notice that this catalyst is a negative catalyst, isn't it? It's a negative catalyst. What is the name? Tetraoxo what? Phosphate 5. What is the name? Tetraoxophosphate 5, okay, acid. It decreases the decomposition of what? Of hydrogen peroxide. This is hydrogen peroxide, H2O2. Are you getting it? So it decreases So meaning that an example of a negative catalyst is what? Take note, tetraoxophosphate 5. This catalyst, tetraoxophosphate 5 is what? An example of a negative catalyst. Okay, now let's discuss the meaning of promoters and inhibitors. Okay, promoters and inhibitors. Now you notice that from the word promote is to what? Promote something, to make something good, to make something move forward, isn't it? To promote something. What about to inhibit, meaning to like cause hindrance? Are you getting it? To cause something like so that that thing will not function well, that thing will not wait, that thing will not move forward. Are you getting it? So in the aspect of chemistry, let's understand the meaning of promoters. Now, okay, now right. These are okay, these are not the catalysts themselves, but they influence the of rate of a reaction. They influence the rate, okay? They influence the rate of a reaction by affecting the efficiency of the catalyst. Okay. For example, the ion, which is Fe as a symbol. You are a chemistry student, so you don't expect me to be spelling all these things. This is a symbol of ion, right? So let's continue. The ion catalyst, okay, used in the Haber process used in the Haber process for the production of ammonia. Ammonia, that is this, right? For the production of ammonia is what is activated by the addition of trace amounts of aluminum oxide or molybdenum. Okay, now these promoters, they are not the catalyst themselves. So I get me. They are not the catalyst. But what they do is to what improve their efficiency, like they are working um like how will I even put it? Like their working condition for them to for that particular catalyst to work very well, you can try to what activate it with another substance. Are you getting it? Do you know that if let me say sometimes in life you might be very down and if your friend comes around and try to motivate you, you will at least it will get to a point you will feel what motivated and you will try to move on in life, isn't it? Even when you are weak, when that friend encourage you, are you getting it now? So promoters are a form of your friend. Are you getting it? So meaning that for that catalyst to be activated, there is something we call promoter that will come and what back it up to what activate it. So those things that what activate the working of a catalyst, we call them what promoters. Are you getting it now? So for example of a promoter, look at it. We said something. One of the reactions where we use iron, the production of ammonia, the production of ammonia, the catalyst used is what? Iron. Check your book. Don't forget all these things. Okay. So the production of ammonia is also called the Haber process. Don't forget. You can write it down. We get to this Haber process too is in a different topic. So we get to that topic. We say, okay. So take note, the production of ammonia, that is what the Haber process. Okay. So now, for the production of ammonia, ammonia is activated. Look at it. Okay. Ammonia is activated, okay, is activated by the what addition of trace amounts of aluminum oxide or molybdenum. So what are the promoters here? The promoters are what? Aluminium and what? Molybdenum. Are you getting it? So they what activate the catalyst, which is the iron, to function well. Okay, so the example, so if they ask you which of the following is an example of this thing, a promoter. So take note, aluminum is a promoter, molybdenum is a promoter. Don't forget. Okay. Now, what are inhibitors? Are you getting it? Now, okay, let's just try them. So inhibitors meaning they will be the opposite of what? Promoters, right? You can call them inhibitors or catalyst poisons, okay? Catalyst what poisons, okay? Now, hydrogen sulfide, comma, arsenic, arsenic trioxide, comma, okay, hydrogen cyanide, and mercury salts are catalyst poisons or inhibitors. Okay, poisons. So full stop. So inhibitors, or you can call them inhibitors or catalytic poisons. Okay, now look at it: hydrogen sulfide, arsenic trioxide, hydrogen cyanide, and what mercury salts are catalytic poisons or inhibitors. Okay, so what they normally do is promoters, they activate or improve the efficiency, the working of what um this thing, the catalyst. Why this thing catalyst poisons or inhibitors They do what? They are very harmful. They harm us by what? Inhibiting important enzymes in our body. They fight against important enzymes when you take in, okay, fight against important enzymes in our body. Now, write down these statements. Very, very important. Okay, when excess carbon dioxide what is the chemical formula of carbon dioxide? Try to know chemical formula, so it's very important. Are you getting it? Carbon dioxide. This is oxygen, okay? That is CO2. Make sure you know chemical formulas. It's very important. Are you getting it? So when excess carbon dioxide, okay, when excess carbon dioxide is passed through lime water, is passed through lime water, comma, a milky suspension, of insoluble calcium, what? Triazocarbonate 4, calcium triazocarbonate 4. This is a chemical formula. Okay. Calcium triazocarbonate 4 is what? Is formed first. Okay. Full stop. Then this disappears after some time to the formation of soluble what? Calcium hydrogen soluble what? Calcium hydrogen triazocarbonate 4. Okay, hydrogen trioxocarbonate 4. Okay, oxocarbonate 4. Now look at it. When excess carbon dioxide is passed through lime water, what will happen? A milky solution, that is insoluble calcium triazocarbonate 4. It is milky in color. Don't forget, even this one, all these are past creation. Please take note of them. When excess carbon dioxide is passed through lime water, what will happen? A milky what? The calcium triazocarbonate 4 is milky in what color? Are you getting it? It will be formed. That is the first thing that will form. Now it will now what? Disappear after some time. Okay, after some time to form what? Soluble calcium hydrogen triazocarbonate 4. Okay, the first one that was formed, that is calcium triazocarbonate 4, it is milk in color, isn't it? But it is what? Insoluble. But the second one that is formed is what? Hydrogen triazocarbonate 4. That is calcium hydrogen carbonate 4. Carbonate 4 is the second one that is formed, but it is what? Soluble. Okay, so if this clear solution is heated, the reverse reaction will what? Take place again. Okay, milkiness will take place again. Okay, so take note. I think we are in number what? Okay, let's do the last one, which is thermal dissociation. Okay, now this one is very brief. Let's just do it very fast, right? In thermal dissociation, comma, each molecule of a substance dissociate it into two or more simpler molecules or atoms on the application of what? Heat. Okay, unlike thermal decomposition. So that is full stop. Okay, so meaning that thermal dissociation is reversible. I've explained the meaning of reversibility, right? Thermal dissociation is reversible. So take note, meaning it can be what? Reversed. Okay. So now example, just write this down. O4. What is the name of this compound? Dinitrogen tetraoxide. Okay. Let me just write it out before you see. Look at it. Dinitrogen tetraoxide. Now take note. It's a gas, so we have forward. We said it is what? Reversible. So we have this is heat. Okay. Then this one. What is the name of this compound? This one is 2. Okay. Nitrogen dioxide. Okay. So take note, at 140°C, then this one is cold at 20°C. So take note. So this is the meaning of thermal dissociation. Okay. Thermal what? Dissociation. Now, one main difference between decomposition, okay, one main difference, okay, between thermal dissociation and thermal decomposition, if you still remember, the main difference is what there, or is the reversibility. Okay, reversibility. Take note, thermal, read your book. So thermal decomposition, okay, thermal decomposition is irreversible, while thermal dissociation is reversible. That's why if you check the example I gave on this thing, thermal decomposition, okay, thermal decomposition, you notice that it contains only what, one single arrow moving forward. But in the aspect of thermal dissociation, it contains what, two arrow, one going then one coming back. Reversibility. Are you getting it? So take note. So meaning that thermal decomposition is what, irreversible. It cannot be reversed. Okay. While thermal dissociation is what, reversible. You can reverse it. So we've come to the end of this lecture or this lesson. Okay, so we are still left with oxidation and reduction where we learn out, because we see questions there too where they will ask you to calculate oxidation number. Don't forget, okay, it's very important, so I will drop there. So make sure you click on that subscribe button, subscribe to this YouTube channel. You are not paying any money. Click on the subscribe button. Are you getting it? Subscribe and click on the notification bell so that once I upload new video, YouTube will notify you. Are you getting the point? Alright, so if you're interested in joining my Jamb lesson group, you can see the WhatsApp number on the screen. Chat me up on WhatsApp and start preparing. Read your books. No, we say go write, you're going to live. No, read your books. I get it. Read. Alright, I wish you the best. Thank you for watching. Bye.